The purpose of this video is to do a quick roundup on number patterns and in particular what may be asked in the exam. So the main skills that can be asked in the Leaving Cert exam for number patterns. The general term for any arithmetic sequence is Tn equals to a plus n minus 1 d, where a is the first term and d is the common difference. So when we talk about an arithmetic sequence, we talk about sequences like the following: 2, 4, 6, 8, where you can see that our common difference here is 2. So this sequence increases by 2. When we look at a sequence like this, we can see that the first term, which is a, is 2. And then when we look at d, which is our common difference, that is also 2 in this case, as you can see here. So the general term just allows us to make an equation that represents that sequence, so that when we're trying to find out the 100th term, let's say for example, of this sequence 2, 4, 6, 8, then all we have to do is put in n as 100, and that will give us the term, the 100th term. So in order to write the general term for this, we have Tn equals, we know that a is 2 plus n minus 1, that doesn't change, and our d in this case is 2. And then it's a little bit of linear algebra, just simplifying that, so we get 2 plus, now remember you need to multiply in this 2 into the bracket on both sides, so I get 2n minus 2, and what we can see here is that in this sequence, our first term and this here cancels. 2 minus 2 gives me 0. So this is represented very simply by 2n. So now if I wanted to find T100, all I would have to do is substitute 100 into n there. And I know that my 100th term then would be 200. The second type of sequence that is very common in the exam is what's called a quadratic sequence. And you would have seen this before when we looked at quadratic equations in algebra. So the layout is very, very similar. A quadratic sequence is a sequence where the nth term is of the form Tn equals to an squared plus bn plus c, where a, b and c are elements of the real number system and a cannot equal 0. And remember I said before that what we mean there by a cannot equal 0, well, if a was equal to 0 in this case, 0 by n squared would give me 0, which means it would no longer be quadratic. So we would have seen this before. I would have told you before that when we're writing a quadratic equation, we always need to make sure it's in the form ax squared plus bx plus c. So it's very similar to algebra and quadratic equations. Okay, so let's take an example then of a quadratic equation. So how do we know that this is a quadratic equation? Well, when we look at the difference between each term, so 3 and 6 is 3, 6 and 13 is 7, 13 and 24 is 11, 24 and 39 is 15. And this is our first difference. So when we were looking at linear equations, we talked about common difference. In quadratic equations, we see that this is our first difference. When we look at the second difference, so the difference between 3 and 7 is 4, 7 and 11 is 4, and 11 and 15 is 4. This is our second difference. And we can see and we know that we have a quadratic equation once the second difference is constant, meaning that we get the same number across the second difference. So now let's look at a question where they may ask us to find Tn, the general term of the sequence, and we're going to use that quadratic sequence that we had from before. So step 1, the first thing we would do is we would find out what our a is going to be. And our a is equal to the second difference divided by 2. So we know in this one our second difference is 4. So a is equal to 4. divide by 2, which is equal to 2. So that's our first bit of information that we get. In step 2, we need to find expressions that would represent some of the terms of the sequence. So looking at our quadratic sequence here, we actually can label these terms. So we know that this one here is T1, this one here is T2, this one here is T3, T4, and finally T5. And what we can do here is that we can actually use this general term to figure out, to make two linear equations that we can then solve simultaneously. So when we look at that, we can see that T1, so we're going to write something to represent T1. Well, we know our A term, first of all, is 2, and we have n squared. And then we have plus bn, we don't know b, plus c. And we know that that's all equal to our first term of 3. Now we can replace those n's with 1, because as you can see I have T1 here. So instead of the n we can put in 1. So what we get here is 2 by 1 squared plus b by 1 plus c, and that's all equal to 3, which we can see here is our first term. Simplifying that, then we get 1 squared multiplied by 2 gives me 2 plus b plus c equals 3. And then finally, I'm just going to bring that b, or that 2, over the far side. It becomes minus 2. And what I get then is b plus c equals 3 minus 2, which gives me 1. So now I found the first linear equation that I'm going to use for my simultaneous equations. Now we can use T2. So let's have a look at T2. T2 is equal to 2. We know that we can replace that n with 2, because that's what we have here. 2 squared plus b by 2 plus c. And I need to look back up here and see what our second term was, which was 6. So I can let that all equal to 6. Then if I simplify that, I have T2 is going to be 2 squared, which is 4. 4 by 2 gives me 8, plus 2b plus c equals 6. Final part, I'm just going to bring that 8 across. Becomes a minus 8, we know. And what happens then is I get 2b, so my second term, T2, is going to be 2b plus c equals 6 minus 8, which gives me minus 2. And I'm going to box that because I'm going to need it for my last part, which is step 3, or simultaneous equation. Step 3 part of this is that I'm going to take my b plus c equals to 1 and my 2b plus c equals to minus 2, and I'm going to solve them simultaneously. So b plus c equals 1, 2b plus c equals minus 2. So looking at that, I'm going to draw a line underneath. I can see that what I'll need to do here is I'm going to change the signs of one of those. So I'm just going to go ahead and change the signs. When I say change the signs, remember I mean I'm going to just multiply this top row by minus 1. And when I do that, then I'm just going to rewrite it out so it just helps me see clearer. So I have minus 1 by b gives me minus b. Minus 1 by plus c gives me minus c. And then minus 1 by 1 gives me minus 1. So what I mean by change signs is, another way of looking at that is just to say I'll change the signs across the whole top row. Then I have 2b plus c equals to minus 2. Okay, and I'm going to draw a little line underneath that, and I'm going to look at these in their columns here. So I have minus b plus 2b is going to give me 1b, or what we call b. I have a minus c plus c, we know that they'll cancel, and a minus 1, minus 2, and that's going to give me minus 3. So now I found a value for my b, minus 3. I'm going to take that value and I'm going to sub it back into one of my original equations. So instead of b plus C equals 1. I'm going to replace that B with minus 3 plus C equals to 1. Remember, it has to go back into one of the original equations. So that's this one here, not the one that we changed. Okay. And then when I look at that, I have C equals, remember, I'm going to bring that minus 3 across. It becomes plus 3. So C is equal to 4. The final step is to put that straight back into our formula over here. This one here, our Tn formula, this guy. And then we have a term that represents that sequence. So my step 4 then, I'm going to pop that back into the Tn term that we have here. So Tn equals an squared plus bn plus c. I know now that my a is equal to 2, so Tn equals 2n squared plus my b I found here, that's going to be minus 3n, and then my c is 4. So if I write that out in a better, just simplify that, I get 2n squared minus 3n plus 4. And that's my general term of the sequence. The final thing that could come up on an exam is the sum of a series. So when we're looking at the sum of a series, we only look at an arithmetic series. That is a linear series. So you can see here, here's an example of 1, 3, 5, 7, 9, 11. We know that the common difference there is 2. So it's going up by 2 each time. And this formula is in your log tables. And it gives us the sum of that series. So we have 5 terms there, S5. And we can very easily add them together. So 3 plus 5 plus 7 plus 9 plus 11 equals 35. But if we had something, let's say for example S20, well, S20 would require us to write out all 20 terms and then add them together, which takes a little bit of time. So this formula actually saves us from having to do that. So let's use the formula then to find S5. Using the formula we get, so our n we know is going to be 5, it's just substitution. Open up my bracket, 2, a, my first term is going to be 3, plus, then we have n minus 1, so n is going to be 5 minus 1. And then my d, we know is going to be 2. Then I can put all of that into a calculator, or what I'm just going to do here is I'm going to simplify the inside of that bracket. So 2 by 3 gives me 6, plus I have 4, which multiplied by 2 is going to give me 8. And then I can pop that into the calculator and that will give me 35. And that's just a very quick roundup of number patterns.